What's up, mobile devs? How are you doing? Today we will create together this amazing animation in React Native using exclusively React Native Skia. This means that we will use neither reanimated nor touchHandler as usual, but we will make this animation entirely in React Native Skia. If you are unfamiliar with React Native Skia, please know that this tutorial will start from scratch, as always. However, if you want to learn more about React Native Skia, I clearly recommend William Candillon's channel, which I will leave in the video description. I would like to specify that this animation is heavily inspired by an animation developed by Philip Davis on his Twitter account. Also, a few days ago, I noticed that a guy named Ashu also shared on Twitter a very interesting implementation of this animation in React Native. The approach used is very different from this one presented in the video, but his result is much closer than mine to the result that Philip Davis achieved in SwiftUI. So if you are interested, you can find his source code in the video description. Regarding the implementation of this animation, the goal will be to tackle it by first trying to achieve step 1 and then step 2. These two steps look considerably different, but they are almost the same on the code side. Before proceeding with the code, I would like also to thank those who are supporting me on the Buy Me a Coffee platform, even when I'm not consistent with the videos. In particular, I want to thank Yal Montufar for offering me 18 coffees in one day. It's because of this support that I had the strength to defeat laziness and make this video. So thank you very much. That said, we can finally move on to the code part. So here I've created a new React Native project with the Expo CLI, and in this project I've already installed the React Native Skia package. So here, in order to use React Native Skia, make sure to use to have at least the version 46 of the Expo SDK. Since the React Native Skia package is supported on the Expo Go app just by the Expo version 46. So if you want to code along with me, make sure about that, or if you prefer, you can use the React Native CLI or the Expo Dev client. So that said, we can already start actually to code, and we can start by adding the Canva component. So the Canva will actually wrap all our Skia components, and here we can specify flex 1, and I think it's fine for now. Actually let's specify also a background color equal to red to see something. Here we need to clean a little bit the container style, and here it is. So the error right now is that we need to handle the Canva children. So basically what we are going to do here, the main goal for now is to display a grid of squares. And in order to do that, we are going to map over two different arrays, and we are going to map over a kind of square amount on the horizontal axis parameter and on the square amount vertical parameter. So I know it is a little bit abstract for now, and basically what we are going to do right now is just to define some constants. So let's start to define the amount of squares that we want on the horizontal axis. So squares amount horizontal. So for now we just want 10 different squares on the horizontal axis. Let's define also the square container size, and the square container size will be equal to screen width divided by the squares amount horizontal. So here we need to define, of course, screen width, and in order to do that we can simply use the dimensions API from React Native. So let's specify here screen width and here screen height. So that said, of course, this will not be the square size, this will be the square container size, since inside this value we are going to have also the padding. So here let's define therefore the padding, and the padding we are going to set it to 10 for now. So we can define the square size as the square container size minus the padding. So with these constants, we can start to iterate over the squares amount horizontal value. So let's define a new array of squares amount horizontal squares. Let's fill with just a 0 value. We are not going to use this value. And let's take here the index. So inside this array, we are going to iterate again over a new array, and we are going to consider the squares amount vertical parameter. We are going to fill it with 0. We are going to map it, and we are going to take a different index. So here we do need to evaluate this squares amount vertical, and we can easily retrieve this value from these constants that we have defined over there. So here let's define the square amount vertical, and we can evaluate the square amount vertical by simply dividing the screen height by the square container size. So here it is. So of course we want that this value is a number, and that we need to round it. So we can simply use the matfloor function. So after all, we can finally define here our rectangles, so our little rectangles. And we are going to define the x equal to I multiplied by squares container size, since we need to account also the padding inside the x. We are going to define the y equal to j multiplied by square container size. And we can define the width equal to square size, and the height equal to square size. So here there is something going wrong. So squares container size, it's fine. Square size also it's fine. So let's reload. Okay, everything is working nicely. It was just a problem with the reload. So here React Native is complaining since we need to assign the unique key identifier to these rectangles. And in order to do it, let's just specify here I and let's say j. So here let's specify I and j. And I believe it looks almost fine. So let's also add here padding divided by 2 to shift a little bit to the right. And here, let's say padding divided by 2. So we can actually reduce the amount of squares on the vertical axis. So let's say here -3. And here we go. So the goal for now is also to center this canvas. And in order to do it, we are going to pass here the width and the height, so the canvas width and the canvas height. So we need to retrieve these different values. So we can define here the canvas width, and the canvas width will just be equal to screen width. Instead, the canvas height will be equal to squares amount vertical multiplied by actually squares amount vertical multiplied by square container size. So here the canvas height will be a little bit different since we need to take in account the squares amount vertical. So here let's pass the width equal to canvas width and the height equal to canvas height. So finally we just need to center. So let's say justify content center and align item center to the container style, so the style of this view right here. And we can move the background color to this view right here. So honestly, I believe this was the complex part. Actually, there are really a lot of constants, but I believe that these constants are all very, very simple to understand. And we are going to use later these constants probably a lot. So we need to make a few changes. Here we are using a rectangle, but I think it will look better with a rounded rectangle. So we can import the rounded rectangle from React Native Skia. Let's specify also a radius, a border radius equal to 4. And here we go. So basically what do we want to do right now? The goal that we want to achieve is to convert, of course, the background color to a black background color, and we want to apply the sweep gradient over all this rounded rect. So in order to do that, I'm going to use simply the sweep gradient provided by the React Native Skia documentation, and I'm going to paste inside this rounded rectangle. So we need to import the back object, and here we go. So let's also convert this background color to a black background color. Okay, and let's also update the center of the sweep gradient. So we want to center with x equal to canvas width divided by 2 and y equal to canvas height divided by 2. So here it is. So actually this approach works, but I believe it isn't the best approach. We can simply use the group component from Skia in order to achieve the same result in a different way. So basically the problem is that here we are mapping over a lot of elements, but we can simply add here the group component from React Native Skia. We can wrap all these squares with the group component, and we can paste here the sweep gradient. And basically what we are saying is that we are saying to Skia that we want to apply this sweep gradient over all this rounded rectangle. So without the group component, we can see that it will not work. So we need it. And here we go. So right now the first part is kind of complete, but of course we need to add a lot of logic inside this rounded rectangle component. So in order to add a lot of logic, probably it is better to create a separate component. So let's create it inside the components folder, and let's create here a component called rounded item. So here it is. I'm just using some snippets, but under the hood here we just have a simple functional component with no props for now. And we want to copy this rounded rect right here. So here we go. So here we need to pass all these properties to this component. So in order to do that, I cannot simply use here the rounded rect props. So I wasn't able to find a solution to this problem. So I'm going simply to replicate all the rounded rect props inside these rounded item props. So here we are going to need an x value that will be of type number, a y value that will be of type number, also a width and a height. So I believe for now it's fine. So let's say here simply square props, and let's pass it over there. So here instead of using rounded rect, we can simply import rounded item, and hopefully it is going to work. And here it is. So nothing is changed, of course. We have just shifted the rounded rect component to this rounded item. So the point right now is that we are going to access we need to access the point that we are clicking on the canvas. And in order to do it, we need to wrap this canvas with a kind of gesture detector. Of course, we are not going to use React Native touchHandler. And in order to do that, we can simply declare and find a way to handle the onTouch callback for this canvas. So in order to handle this onTouch callback, we can create here a touchHandler by simply using the use touchHandler hook from React Native Skia. So here we are going to use the onStart callback, the onActive callback, and the onEnd callback. So let's assign here the touchHandler. So all these callbacks have some events. And for now, let's just focus on the onActive callback. So the point is that we want to retrieve the current position that we are clicking on the Canva kit, and we want to retrieve the X and the Y value. So here we have the X, and here the Y value. So probably it is better to write it inside an object. And let's reload. So you can see here that we are totally able to access the X and the Y coordinate. So the idea is that we need, of course, to access this coordinate also inside this rounded item, since we are going later to find a way to scale the square related to the distance to this square point, to the square position, from the square position to this point that we are clicking. So in order to do that, in order to pass this value to this rounded item component, we need to create a kind of Skia value. So it is a very similar concept to the shared value from Reanimated, but it will be simply a Skia value. We are going to call it a touched point, and we are going to use the hook use value from React Native Skia. So here it is. So at the beginning, of course, the touched point, we are not going to touch anything, so the initial value should be equal to null, and the type should be equal to X number, Y number, or null. Simply because when the touched point has a specific value, we need to specify to use this type, otherwise it will be null. So here, inside the onActive callback, we can write touchedPoint.current equal to this object right here. And by doing that, we are simply moving the object, the position object, to this touched point, and we are able to pass this touched point to this the rounded items. So here the touched point is simply a Skia mutable value. We can copy that, and we can specify here the point inside the rounded item props. So here, let's take it the point right here, and let's pass the point over there. So basically, what do we want to achieve? So we just want to scale the square based on the distance to this point. So here we can easily retrieve the square position from the square props by simply accessing the X and the Y position, the X and the Y values. And we can compute the distance based on these values right here and on this point. So here, let's define the distance. And of course, we need to check if the point is null. So if the point is null, we are simply going to return 0 for now. Otherwise, here we can evaluate the effective distance. So here I'm simply using the Pythagorean theorem in order to get the distance. And here we can apply the square root. So actually this is not completed. So basically the distance will be, since this distance is highly dependent from this point, and this point is a Skia value, we need to wrap everything inside a use computed value. So you are going to see it in a while. And basically the use computed value is very similar to the use derived value from Reanimated, is an hook provided by React Native Skia, and it needs to be used when we are computing a value based on other React Native Skia values. For instance, here the distance value is depending from this point Skia value, and therefore we need to specify inside this computed value, inside the computed value dependency, the point Skia value. So hopefully it was clear, but by the way, we are going to use this use computed value over and over again. And in fact, right now we want to evaluate the scale. So basically what will happen, right now we have the distance between the touched point. So for instance, I'm clicking this touched point, and from each square we have evaluated the distance. But basically what we want to do, we want to understand how much we need to scale the square based on the distance. So of course, what is the expected behavior? We want that if the square is very, very far from our point, we want to scale down the square. Otherwise, if the distance is very small, we want to keep the scale almost equal to 1. So let's write that into code. Let's define here the scale. So of course the scale value will be highly dependent from this distance value. So we are going to use again this use computed value hook. And here we can already write inside the dependencies that we are going to depend from this distance Skia value. So basically, in order to achieve what I just said before, we are going to interpolate the distance value. So basically, scale value will be equal to interpolate. So here I'm using the interpolate function from React Native Skia, and we are going to interpolate the distance value. Here we are going to specify the input range and the output range. So basically, what is the expected behavior? We want that if the distance is close to 0, we want that the scale is equal to 1. Otherwise, if the Skia, the distance has reached the max distance, so if it is very, very far, we want to specify the scale value equal to 0. So, of course, in between, the scale value will just be interpolated between these two values. So if you are not familiar with the interpolate function, I've made a lot of video about that. Of course, it isn't the interpolate function from Skia, but if you are familiar with the interpolate function from Reanimated, it is basically the same thing. So, of course, here nothing is working anymore, and that's because we need to specify which is the max distance. So basically the max distance that we can have between a touched point and a square is easily retrievable from the Canva width and the Canva height, and we can apply the same Pythagorean theorem in order to get the max distance on the Canva. So here, let's go back on the app.tsx file. And let's write the max. Let's evaluate the max distance. So basically, we are simply going to consider the square root of Canva width squared plus Canva height squared. So basically, it is simply the diagonal of the Canva. So we can export it, and we can import it right here. So we can return the result, and here we are going to deal with the scale value. So here, before moving on, let's just resolve this little warning that we have. So basically, we have a required cycle problem because we are importing the max distance from app, but the app itself the app file itself is importing the rounded item. So we have this cycle. So in order to solve it very easily, we can simply create a constants file, and we can move all the constant inside this file. So the solution will work since we are going to import the constant file from the app and the constant file from the rounded item file. And here let's import dimensions. So I'm going to export everything. And here let's also fix all these issues. So of course I'm just importing things that we have already evaluated, so nothing new. We are just solving this required cycle problem. And here let's import max distance from constants. So we no longer have the required cycle problem. So right now we have evaluated this scale property, and we can finally apply the scale property to this rounded rectangle. So the easiest way to do that is to simply update the width and the height properties by evaluate again by recompute the width property with the scale value and the height property with the scale value. So we can define the scale width equal to use computed value. It will depend from scale, and we are going to multiply scale.current multiplied by the square width. So multiplied by width, and we are going to retrieve the scaled height by multiplying by the height. And here we can simply pass the width, the scaled width, and the scaled height. So here it is. And now finally we are able to see something. So of course the animation isn't completed yet. Basically you are going to just by releasing the finger you can see that nothing is happening, but of course we want to scale back everything as it was previously. And this thing is not complex, of course, but it's not that trivial. So basically what do we want to do? So first of all, we want to set the touchPoint.current equal to this position also in the onStart event. And we want to set touchPoint.current equal to null on the onEnd callback. And here we can see at least some improvement. So of course that's more or less the behavior that we want to achieve, but we don't want this glitched effect. We want to smooth down this animation, this progress animation. So in order to do that, we can define here a progress value, and the progress will be equal to 0 at the beginning. So let's so basically when we are going to start the gesture, we are going to set the progress to value 1, and on the end we are going to set progress to value 0 by using the timing animation, and then we are going to pass this progress value to this rounded item, and we are going to smooth down this animation. So in order to do that, let's run a timing animation. So in the onStart callback, we are going to run this animation with a duration of 300, and we are going to do the same here. So of course in the onEnd callback we are going to animate back to 0. And here let's see, the progress is a Skia mutable value. So let's add this parameter right here. And let's pass in the rounded item. Here we can retrieve the progress value, and we need to find a way to use this value in order to smooth down the animation. So in order to achieve this result, one idea consists into smooth down this distance parameter in order to smooth the scale interpolation. So for instance, we can simply multiply the distance.current with the progress.current value, and the progress.current value is just a value that is updating itself between 0 and 1. So here we need to consider, of course, the progress into the dependencies. So let's reload. And we can see at least that at the beginning we have some improvement. So you can see that at the beginning the animation is of course smooth, but at the end it isn't like that. And that's because in the onEnd callback here we are setting the touch point dot current equal to null. Therefore the distance will return 0. So since the distance.current is equal to 0, this progress.current it isn't helpful anymore. So we need to find a way to keep actually the old position, the old distance. So instead of returning 0, we need to find a way to return the previous distance. So in order to do that, we can define a new actually Skia value by using the useValue hook. So the initial value will be equal to 0. And if point.current is equal to null, we just want to return the previous distance. Otherwise, we want to store this value into the previous distance.current, and we want to return previous distance.current. So let's reload, and we can see that everything is working perfectly. So basically our first step has been completely achieved, but right now we need to find a way to create this incredible 3D sphere. So in order to get to this point, we need to observe first of all one thing. So here in the animation, we can see that basically we are just scaling down the width and the height as expected, but we are not scaling this width and the height with a specific origin. So we are just reducing the amount of the width and the height, but it isn't the square, it isn't transform itself over the center of each square. So how to do that? So how to use the transform API and to use the scale parameter. In order to do that, one ideal solution is to pass the transform right here. But of course we cannot do that. That's not a React Native component. And in order to apply the transform property, we need to wrap the Skia component with the group component. So here it is. And the group component will have the transform property. So the transform property can be a constant or it can be a Skia value. But here, for instance, we cannot write scale equal to scale.current. So we cannot use, and that's because we cannot use the Skia value in this bare way inside this component. So what we can do is to create a transform Skia value, so a transform computed value based on this calculation. So let's specify here the transform, and let's return simply this array. So here we can pass the transform Skia value, and we need to specify actually that the transform depends from scale. So here I believe we can get rid of the height and the width, and let's return. So by doing basically nothing, automatically something is moving around in a very, very glitched way. And the reason is quite simple. So basically by default, the transform will be applied by considering the center equal to the point 0, 0, and the point 0, 0 is this one. So basically we are scaling everything. We are scaling everything by considering as the center this point right here. So for now, let's do something a little bit different, and let's try to consider as the origin of each square the position, the center of each square, since we want to scale each square by considering its own center. So in order to do that, we can specify the origin parameter. And here the origin parameter will be simply equal to x plus the square size divided by 2, or simply width divided by 2, and y equal to y plus height divided by 2. So let's reload. So I know that, let's say this explanation was cumbersome, but everything is working as expected. So we are scaling nicely the square by considering the center. So the animation is a little bit different between the previous one. Previously we were just using the computed scaled width and the scaled height property, but we were not scaling the center by taking the center of the square as the center of the transformation. So here we can get rid of these two computed values. And honestly, we can also get rid of this origin. So let's return back to this glitched behavior. So basically what we can see that we are not getting, of course, the expected sphere, but we are getting something similar. And in fact, by centering this, the cursor on the 0 position, we are getting more or less what we would have expected in the final animation. So what is the problem right now? The problem is that the origin of the transformation is always equal to the point 0, 0. But what we can do is simply update the center of the transformation by considering the touched point position. So hopefully that was clear, but you are going to see in a while what I'm talking about. So basically here we need to find the new origin, and we are going to compute the origin of the transformation by considering the point current value. So actually, if the point current is equal to null, we are going to return as origin x equal to canva width divided by 2 and y canva width, canva height divided by 2. So just the center of all the canva. Otherwise, we are simply going to return point.current. So here we need to specify the point dependency, and we can specify here the origin Skia value. So let's see what's going on. And we can see more or less something quite similar to what we were expecting. So here, let me check. So in order to get a better animation, I believe that one simple idea is to reduce the amount of squares. So let's go inside the constants. Instead of 10 squares, let's just get 8 square. And let's increase the padding to 20. So here we can see a better animation. But we want to scale a little bit more to 0, so we want to scale down a lot more squares. And in order to do that, we can simply reduce this interpolate max value inside the input range. So basically we want to square faster, we want to scale down faster, And in order to scale down faster, we can simply divide the max distance by 2. And here we are almost seeing our perfect sphere. So basically, we have a little glitch. So here you can see that there are few squares in a strange position. And that's because by making this change, what will happen? Basically, some values that are with a distance between with a distance that is greater than max distance divided by 2 will have a scale value that is less than 0. So we'll have a negative scale value. So in order to prevent this behavior, we can simply extrapolate left and extrapolate right. So let's specify here extrapolate.clamp and extrapolate right equal to extrapolate.clamp. So let's reload. And here we can see that we don't have anymore this glitched behavior. So the animation looks almost completed. And it's quite nice, but we still have a little problem. So you can see here that by releasing the point, the finger, we are getting this glitched behavior somehow. So it's quite glitched, as you can see. And that's because here the origin of the transformation is this change is quite fast. So basically, if the point.current is not null, we are able to return easily the origin of the transformation. Otherwise, automatically the origin of the transformation will be equal to the center of the canvas. In fact, you can see that the animation is working fine just in the center of the canvas, but here we have this glitched behavior. So in order to solve this problem, we can do something similar to what we have done previously with the distance. So we can create a previous point. So here, let's create a previous touched point. And this one will have this default value. And we are going to return, so if the point.current is equal to null, we are simply going to return the previous touched point.current. Otherwise, we are going to store the point.current inside the previous touched point.current, and we are going to return the previous touched point.current. In this way, the center of the transformation will not change instantly. And you can see that the effect is much better than before. So I believe that the animation is completed actually. And this effect is quite magical, and it's a very, very interesting effect. Honestly, it was achieved by luck while trying to create a new video for this channel. But I'm very, very happy with this end result. I highly recommend you, by the way, to check out the other React Native implementation that I will put in the video description. And I highly recommend you to check out even the Twitter account of Philip Davis that actually imagined this animation. So thank you very, very much to stay with me all this time. And if you have any kind of feedback on this video or on this animation, feel free to write a comment in the section below.